So let's consider like a boat on the water. Okay, so we've got a boat out here on the water. We got a storm off in the distance, and so there's waves coming by. So let's say that the spacing between each wave crest is 35 feet, and each wave is a swell of 4.75 feet above the mean ocean or mean sea level. So that means it goes up 4.75 feet and then down 4.75 feet in the trough. And so I want to know what would be the equation to describe the y as a function of position and time for this. Okay, so we know that y equals a sine kx minus omega t. So k is 2 pi over the wavelength. Well, clearly the wavelength is going to be equal to 35 feet. And so this comes out to be equal to 0.18 inverse feet. Okay, so omega is 2 pi times f. Now f is 1 over period, so that's going to be 1 divided by, and I guess I forgot to mention that as you're sitting there, a swell comes by every 3.88 seconds. So that's going to be your period. So 1 divided by 3.88 seconds. Okay, and so that would be equal to 0.258 hertz. Okay, so you plug that in here, 2 pi times 0.258 hertz, and that comes out to be equal to 1.62 hertz. Okay, and so the amplitude up and down was a 4.75. So if I put all this into my A sine kx minus omega t, then what I find is A is 4.75 feet times the sine of 0.18 inverse foot x minus 1.62 hertz t. And so that gives me my basic wave equation right here. And so then the question would be, okay, given that, okay, now that I have my basic wave equation, I want to know what is y at x equals 10 feet. Okay, so in that case, then y, so at 10 feet and time of 5 seconds. So 5 seconds after I start, 10 feet from the starting point, how high is the ocean water? So that, in other words, how high is the wave? That's what this is asking. Okay, so 10 feet from my starting place, 5 seconds after I start, how high is the ocean surface right here, 10 feet over, and time equals 5 seconds. So this actually gives me an equation for that. So you have the y here, plugging in all the numbers, 4.75 feet times the sine of 0.18 inverse feet times 10 feet minus the 1.62 hertz times 5 seconds, and you plug in all the numbers, and what you get is minus 0.0799 feet. Okay. Now, very important, your calculator must be in radian mode in order to get the correct answer, because this is in radians right here. And so that's what this is all predicated on. And so that needs to be in radians. And so if you do not put your calculator in radian mode, you will not get the correct answer. This is a common problem and a difficulty the students have because they're used to using degrees for some problems, and then now they got to use radians. So when you're dealing with waves, you got to, even with harmonic oscillators, the harmonic oscillator equation is also in radians, and so you have to go back and forth between degrees and radians sometimes on the same test. And so it is a very good idea whenever you do this to check and make sure you're in the correct mode when you're using your calculator. Well, we know that y equals a sine kx minus omega t. So the question then is, what about the up and down velocity? What's the maximum up and down velocity that someone experiences as they're sitting in this boat with these waves going by? Okay, well, we know that the speed of the wave is lambda times f. And so we could do that. We could find lambda times f, so that would be 35 feet times the f, which is 0.258 hertz. And what we come up with is 9.03 feet per second. Okay, that's not the answer to the question, though. That is how fast the wave is moving this way. I want to know what's the speed up and down that way. Okay, so we know that y equals a sine kx minus omega t. So v sub y is dy dt. So that's going to be, if I take a derivative of that, that's going to be minus a omega cosine kx minus omega t. And so Vy is going to be equal to minus 4.75 feet times 1.62 hertz times cosine of kx minus omega t. So that's kx minus omega t. And so Vy is minus 7.7 feet per second times the cosine of 0.18 inverse foot times x minus 1.62 hertz times time. Okay, so that is your equation now for velocity. So Vy max would be when the cosine is going to be at its max. So that would, which is going to be 1, okay, or negative 1. So that would say that the up and down maximum velocity is 7.7 feet per second. Notice that Vy is not equal to the wave speed. And this is why I like to use a different symbol for wave speed than I do for up and down motion. Your book uses V for the up and down motion, and it also uses V for the wave speed, which I think is just confusing. And so I like to use a separate term. Now, I use the letter C for wave speed because we use C for the speed of light next semester. And so we do a lot with waves, electromagnetic waves, next semester. And so I kind of like you to start getting used to using C for wave speed.